This is Chapter 7, SQL for Database Construction and Application Processing. An excessively long title, in my opinion. What's the purpose of this chapter? Main purpose is to write SQL that will create/modify the structure of the database. That may be the table structure or other structures that we haven't really, that we'll introduce in this chapter. And some of that may be the structure of the data as well. So we're going to be looking at how we can use SQL in new ways. This is a new branch of SQL than the query kinds of SQL statements that we've written before, to create tables and change them, to add constraints, to add views. And then we'll also, the second big component of this chapter is how can we mix some logic programming, some actual programming logic into our database application, whether that's in the DBMS or in an external application, to do the kinds of processing that we want to do that's more advanced than we can do with just a straight up SQL query. So we're going to be looking at user-defined functions and triggers and stored procedures as well. In Chapter 2, we introduced these 5 categories of SQL. We only looked at the data manipulation language, just part of that, the select, where. So in this chapter, we're going to continue looking at some more of the DML that we haven't covered, and also look at the data definition language and the SQL stored modules. So we'll let those two things go away and really focus on these 3. So data definition is used for creating tables, creating relationships, and other structures. So this is all new stuff that we hadn't talked about before. In some sense, though, as we've used MySQL, it wrote this stuff for us. Remember when we would design tables kind of graphically, it would write a SQL script, and it was just writing all of the create table with the constraints and all the stuff we're about to learn. We could certainly write it ourselves, and knowing the SQL ingredients was going to make you a better database person. But in some sense, you have been using this DDL before. It was being used behind the scenes for you. The second piece is the data manipulation language. And we used that before, but only on select queries. In this chapter, we're going to add in the other kinds of modification queries. That would be delete, update, and insert. So adding new data to the database, changing existing rows, and deleting rows from the database. So none of those are really earth-shattering new ideas either. It's just this is the SQL syntax to do it, and it's fairly straightforward. The last piece is certainly the most complicated, and that's because it's doing the most complex thing, and that's the persistent stored modules. What this means is we're going to add real programming capabilities into the mix. So we're actually going to have loops and if statements and that kind of programming logic. Variables, control of flow statements, all kinds of normal programming stuff, which you're used to in languages that you've used, like .NET languages or Java. And we'll see some new database-specific languages that databases support that allow you to do that kind of programming logic. So the first category is the data definition, DDL. And this category of SQL is about creating tables, creating relationships within those tables. It also includes creating other structures like views that we're going to talk about in this chapter. Second category that we're going to look at is the data manipulation language, which we've already seen in SQL select statements, but we, in this chapter, are going to extend that to the other kinds of operations on data that are common. This would be creating and modifying data. That would be inserting data into the database, updating data, existing rows, and deleting rows that are in the database. And the third piece that we're going to add here is the most complex, and that's the persistent stored modules. And what this means is we're going to mix in real programming into SQL so that we can do even more advanced, complicated logic. And we can't do that with just SQL, because SQL isn't a real programming language. SQL is a subset that allows us to generally manipulate database, define database structure, but we can't actually do ifs and loops and variables without these additional capabilities that the PSM adds in. And we'll see that different databases do this with different languages and with their own flavors. All right, so the first piece of this new set of SQL knowledge is the DDL, the data definition language. And basically this boils down to 4 things. We're going to see that we can create tables using create table, we can alter tables, we can change their structure using alter table, we can delete a whole table using drop table, and we can delete all the data in a table but still keep the table's structure by using truncate table. Do all these things make sense? We've done all this before using the MySQL Workbench graphical interface, but it's really just running these SQL commands for us behind the scenes. Right, truncate table would be deleting all the rows, but the table is still there. Whereas with drop table, you delete all the data, and there's no longer that table in your database. Here's an example. I think this is incredibly readable of how you create a table. So it's create table, name of table, and then you list out the names of the columns, the data types for the columns, and then any constraints on those columns. And we're going to talk about constraints some more in just a second. That's the, I think, most complex part of this. Does this make sense? This is exactly what MySQL Workbench wrote for us when we designed the tables in the interface. Did you guys see this when it did it? I think it would kind of show it to you for a second, and then you click execute query, then it would do it and make the tables. So there's a ton of data types that I don't really want to go into. I would say just they're slightly differently named in different database products, and they certainly have different ranges for the different things, different properties for these data types, and you should pick the data type that's most suitable for your problem, and you'll know about that when you're doing your problem. A couple more data types here as well, string data types and datetime data types. So pick what's right. I suggest that you look at the documentation when you need to make a database. I wouldn't suggest that you just memorize this table. I don't know, that's just me. All right, so let's talk a bit about constraints, because this is the more complicated part. Let me show you this kind of more complex SQL create statement. We're creating 2 tables here that have relationships between them. And as I go over each of these constraints, see if you can find the constraints in the query, in the SQL statement. It's not a query anymore, right? Because it doesn't actually get us results back. It's really executing and doing an operation. So the primary key constraint, you see that at the bottom there on artist PK, says this is the primary key for this table. It's the way you define the primary key. We can specify that certain values have to be unique. See, in that case, in the top example, the last name, first name combination is supposed to be unique. We specify if a value is allowed to be null or if it cannot be null. Primary keys have to be non-null. We can specify foreign key relationships by saying this is the foreign key. You see that at the bottom, the constraint artist FK, foreign key, artist ID. And we say that that references artist ID. We also get to specify there what happens on update and deletes. So because of that relationship, if we delete a value, do we have to propagate that delete up or propagate the update down? Okay, the identity, I believe, means, like that identity 500, 1 means start at the number 500 and increment by 1 every time. We usually just start at 1 and increment by 1, but you could specify that if you wanted a certain range. The last one is this check, which is even more generic, and basically you can put in check a similar syntax to what you'd put in a where clause of a select query, and force the data to be sort of a certain format. You see there where nationality values check, and it has to be in that list of strings. So just a way of enforcing some data format constraints. Okay, so this is all related to create table, but it also generally applies to alter table as well, because alter table allows you to change any of those things. So this is an example of how we would alter the table named assignment and add a foreign key constraint. So if we didn't add the foreign key constraint when we created the table, we could add it later using alter table. You do the same kinds of things, the same syntax that comes after alter table, but then you'd have add and then something, whether it's a constraint or we can also add or drop columns if we just want to delete a whole column from the table. Let me give you an example of that. So If we want to add a column to the table, you see here we're adding the column my column and giving its data type and constraints to the customer table. If we want to delete a column, we use alter table, table name, and then drop column name. Drop table is the way that we remove entire tables. So drop table customer would get rid of the table and all its data. Goodbye. Be careful with that. If a table has constraints, though, the database won't let you drop it. So if you need to delete a table that has constraints, you have to remove the constraints first, and then you can drop the table. So that's what this second example shows is we have to alter the table and drop the constraints, both of them, before we can drop the table itself. And lastly, the truncate table, amazingly simple syntax, would just delete all the rows from a table. You can't do this with a table that's referenced by a foreign key constraint because those dependencies still exist. All right, so that is the DDL, the data definition language, that piece of SQL. Next, we're going to talk about the data manipulation language and look at these 4 new operations that allow us to actually change data in the database. So there's insert, update, merge, which is similar to update and insert kind of together, and delete. So those are our keywords that are going to be used in SQL commands. How do we insert a single row? This is the syntax. So we say insert into table name, and then in parentheses, the names of the columns that we want to insert into. And in the same order, we say values, and then parentheses, a list of values that should correspond to the values of the columns in the first line, or this line. Tamayo should go with last name. So this is how to add a new row to a database table. Sometimes we want to insert a lot of records at once, like if we've imported a bunch of data into some raw import table and then we want to pull some over. This is a sort of like an embedded query where we, in black, select last name, first name, nationality, date of birth from this table imported artists, and then we insert all of those into artist using that insert into and then parentheses statement. So we're moving records from one table to another table. This the imported artist may have a bunch of other fields as well. Maybe we're normalizing this database. You know, we get a big spreadsheet kind of thing. You know, a denormalized data set, and we're picking out some of those fields and putting them in artist. This would be a way to do that. Update works in a very similar way. So update means I'm changing the values in an existing row or set of rows. So if I want to update table name, in this case customer, and I want to set the city is the field, equal to New York City, but I only want to do that where customer ID equals 1,000. So this would be probably, I would think customer ID is a primary key, so it's unique. So this would only be updating one field in one row of the database. If we wanted to update a bunch, we could do that by setting our where clause more liberally. So we're going to here update customer where we're going to set the area code to 333 where city equals Denver. So this could apply to lots of rows. All right. This third one is new to me. I don't know, nobody ever talked about it. I never seen it before, but it's kind of cool. It's sort of a combination of update and insert, where you can say if you find a row that kind of is already existing that matches this data, then update it. But if you don't find a row that matches this new data, then insert a new row. So you can kind of see that on this one. So we're saying when this thing matches, then we update it using this rule. But when it doesn't match, we insert a whole new row. See how that's kind of a combination of update and insert, facilitate processing, and kind of merging in a bunch of new data into a table that maybe has some of that data already, but not all of it. All right, last piece here is delete. Just like you'd expect, you would delete from table name where some condition exists. So if we want to delete customer 1000, this is how we do it. This is going to delete a single row because customer ID is unique. Now, what happens if you omit the where clause? Yes. So yes, it would be like truncate, and I think this would be, you would rarely want to do this. So watch this. It blinked. You should probably never do that. I almost put be careful with this in Comic Sans just to like drive home how dangerous and horrible this slide is. All right. Last little tidbit here, something y'all already learned through using the SQL Zoo, which is aliases, where you can have a new name for a column. There's two formats, different databases, DBMSs use different syntax, whether you have the word as or not. But it's doing the same thing where you're renaming the customer table C. Right. Next big component here is SQL views. And as you learned from the quiz today, a SQL view is a virtual table that's constructed from other tables or views. So it doesn't have data on its own. It just gets them from other tables or views. You could almost imagine a view is sort of like a pointer, right? So the pointer, like in programming terms, right? You're pointing to the data. It exists somewhere else. You can refer to it. You can like look it up, but you're really just looking at a copy of something that exists somewhere else. There are a couple of standard view creation commands: create view, alter view, drop view, just like it were a table. Again, remember that this is a virtual table. So it looks like a table, but it's not deep down a table. So that's going to affect the way you can operate on it. We'll talk more about that in a second. So these are SQL views. The question you might ask is, why would I want one of these? And they have really a lot of uses. Why would you use views? If you wanted to hide rows or columns, you could create a view that only showed some rows or some columns. If you're going to do a bunch of computations and you want to display that and make it a lot easier for a user, like a database user to use, then they don't have to know the really complex SQL syntax. A view would let them do that. It will, I kind of combine those two. It will let you layer built-in functions. So to me, this makes me think of, did you ever do like any kind of programming in Excel? Or if you had this really complex Excel formula, you could embed a function in another function, another function, another function, another function. But it kind of gets hard to think like that, perhaps. So usually in Excel, you have like, you process the data from one column to another column, and then process that data into another step, and then do another step. You with me? So by using a view, you could kind of do that same thing where you've got this intermediate sequential layering of functions on data. It gives a level of isolation between table data and the user's view of the data. So this is really going to come in handy when you need to have different permissions for different users. You follow me? So we've got this core data that's being stored, but maybe you want your interns at the company having access to this very limited set of the fields, and they can't change anything about it, but they need to be able to see it to do their job. Yeah. Whereas the VP may have access to like all the fields, and he can even edit the fields. So we can create different views for those different users and give them different permissions instead of giving everybody all access or no access to the database and to all the columns, none of the columns. Does that make sense? So it really is a tool to help users use the database more cleanly. Also, you can assign different triggers to different views of the same table, so you could kind of implement different logic at different events using views. This is create view, pretty straightforward, where you're saying create view and then the name of the view as, and then underneath that you've really just written a SQL select query. So when you've created this view, and maybe that looks like this, so it's a first name, last name, only now you call it customer last name, customer first name. So these views provide, right, they're views, so they're really good at being viewed. Can you update a view? The answer to that is most definitely maybe, or no, or yes. It just depends, right? So there's a bunch of kind of complicated questions. If you think about what's really going on, you can kind of deduce, oh, there's no way it could do that. So let's say, for example, your view shows some computed value. Like what if the view showed the total price for a thing, which was its base price plus some 30% markup, right? Could you change that value? in the view. You couldn't because it doesn't connect to an underlying value. I mean, it doesn't directly map to an underlying value. You follow me? You couldn't say, well, the total price is now $100. There's no way for it to go backwards through the views creation. So anyway, sometimes you can update views. If it's a single table and you have all of the required columns in the view, then you could update it. If there are multiple tables, you probably have to use these instead of triggers that we're going to talk about later to handle the more complex processing when in the view it looks like they're all on one table, but in actuality they're in different tables. So you have to have this instead of trigger that's kind of an intermediary that's going to interpret your updates and split them out to the right table. It looks like you're updating one table, but actually there's two. So it's have to split that back to its original table. The authors say that you might have an updatable view if you have a single table and you have some of the required columns. If you have the primary key in the view, then update and delete may be allowed, but insert wouldn't be because you can't insert the required values because they're not in that view and you don't have access to those columns. Does that make sense? So if there are required columns missing, then you can update and delete, but you couldn't insert. On multiple tables, you might be able to do updates if the rows can be uniquely identified. And as I said, if you have computed columns, you're not going to be able to update those, and you can't do an insert without a primary key. So if the primary key isn't included in the view, then there's no way you could insert a new value. All right, that's enough on views. Let's hit this last section now, which is the persistent stored modules. And the idea here is we're going to look at three ways that we can embed logic into our database: through functions, through triggers, and through stored procedures. So generally, we are trying to connect programming into our SQL, into our database. And every major database has a method of writing code inside the database. Microsoft SQL Server has this thing called Transact SQL, TSQL, which is an extension that kind of augments SQL to have these procedural programming capabilities. Oracle has a thing called Procedural Language SQL, PLSQL, slightly different syntax, but the same main idea, right? We're going to program with variables in the database. And MySQL has the same thing as well, but doesn't have a cool name. Oh, poor MySQL. One piece of functionality that is supported by these databases is that you can write a function in these programming languages, in these procedural languages. Those functions could take input, do some processing, and produce some output, just like a function in a programming language. It's the only difference here is that the input is probably going to be values from rows in a database. Let me show you an example. Maybe this is a little bit more interesting. So we're creating a function here. This is in Microsoft Transact SQL. And this function accepts two input parameters, first name and last name. They're both characters of length 25 max. And it returns a varchar of 60 length. So here at the begin and end statement, we define here what this function does. And this is called name concatenation. It's just going to take the first name and last name and put them together with a comma space. It uses the right trim function to get rid of spaces as well. And then it returns the full name. So this is a function that now exists in the database, and other queries could call this function instead of having to implement that themselves. I mean, we know we could do this in SQL ourselves, but this way we've made it more modular and reusable. I'll have a little query too. So this is how you could use this thing. You could say select db.name concatenation, first name comma last name as customer name from whatever table. So instead of having to write any SQL here to get both columns and concatenate them, we move all that to the function and we get to write prettier code here. You can imagine that would be even more and more helpful if the function were very complex. So that is this one first example of persistent stored modules, doing programming in the database. Okay, second way to do this persistent stored modules is with triggers, and there may be some overlap here. The idea here is that we have stored programs, which is what we saw before. I mean, a function is like a program, right? But these are based on events. So there are 3 different types of triggers, basically correlate to when does the trigger happen. Does it happen before the event, instead of the event, or after the event? And then there are 3 different trigger events, which we've seen before, which are insert, update, and delete. A before insert trigger would happen before an insert occurs on a table. We could write a function that happens at that time and apply some logic based on the values in the table and in the update or the insert. If you then look at the combination of these, you can have 9 different trigger types, and not all databases support the same set. So this shows you that like MySQL just supports before and after. SQL Server supports instead of and after, and Oracle supports everything. So these are different events at which time you can execute some code, which would be written in those same languages that we looked at before, or perhaps even other languages too. I think like Oracle you can write in Java. SQL Server I think you can write in .NET languages. Just to give you a visual overview of triggers, you do get access, like on an update, you get access to the old values and the new values. So that's the input to this function that gets fired on the trigger, and then you do whatever needs to happen. So you might actually do the update, or you might not do it, or you might do something in between. That makes sense? So you could enforce like data constraints and stuff through triggers. On an insert, you would get the new values right before they're actually inserted, and on a delete, you get the old values. So you get the stuff that's supposed to make the change or has made the change, and you can determine if you want to do something about it. So let me give you 4 reasons why triggers are useful. For one, default values. Oftentimes, we want to have a default value for fields in new rows, right? So we've inserted a new row, and we want the initial value to be something that means something. If we have a very complicated set of rules to compute, to define the initial default value, you would implement that with some kind of insert trigger. And the book has an example of this, which I guess we'll look at on the next slide. But the main idea here is we have to run some logic that's complicated. It's not just get the current date and time, or it's not just put a 0 in, but it's dependent on other values. So in the book's example here, you see this create trigger, trans, asking price, initial value, after insert on trans. So this means that this happens after an insert. We define some variables there. We do some checking to see if how many rows match this, and we're going to do a different logic depending on if there's only one row or if there are several. You can kind of read through that and see that if on one we just do 2 times the acquisition price. If there's more than one row, then we do a more complex query that will compute some sort of average, I think. This is giving us a place to do this complex logic when we insert a new row so that the right values are there. All right, second reason to use triggers are to enforce data constraints. So there may be constraints that apply where the values in this row always have to be within the boundaries set by other columns in this table, other rows in this table, or other tables altogether. By having a trigger like this, where we look at after inserts and updates and make sure that some value is still appropriate. This has something to do with if the artist's nationality is Mexican, then we have to do some special things to the asking price. Third reason is to update views. We saw that views are special, and they might not actually, they're not real tables, they're virtual tables. So when we update a view, instead of to actually get that change to the underlying table, we might have to apply some more complex logic. And here's an example of that from the book. So instead of doing the update to the view, which we can't, we're going to kind of route that to a different table, the actual table that underlies the view. Lastly, referential integrity. We often need to make sure that the referential integrity constraints aren't broken, and delete is one example of that. The book's example talks about the case when you need to make sure that you can't delete the last employee in the department, or otherwise you'll, I guess, lose the department or something. Anyway, you can make sure that that constraint actually is enforced, that you never delete the last person in a department by using a trigger. So I hope that gives you a little bit of a feel. I know it's a whirlwind tour of what triggers are about. So it gives us a place, a time, before or after an insert, an update, or a delete to do something special based on the specific constraints of our database, which we identified earlier in the data modeling process. Last piece here are the stored procedures, which are procedures, functions, if you will, that exist in the database but get called from outside the database from like an external application. These are procedures that may in Oracle be written in PL, SQL, or Java. In SQL Server, it's transact SQL. The stored procedures can be called from external programs like Java or C# or whatever, where those external applications are sending basic commands to the database to run a function and then getting the response back and doing something with those results in the application. So often this is a way to kind of offload the processing from the client and to do it all on the database server. The database, because it's the database and it knows the database, can optimize the queries and do them better because it can compile the queries. This would allow for perhaps decreased network traffic. You can imagine if, let's say I want to show on a grid on my website all of the widgets that are blue, right? Well, if I had a stored procedure that would do that filter for me and just return me the blue widgets, then that's all I have to transfer over the web is the blue widgets. Whereas if I forced the client to do it, right, if the client has to download all the widgets and then filter them out, client side, would be a lot more traffic. It's a contrived example, but it's an example. Furthermore, this has a lot of security implications, which this may be like the best reason for it. Because the processing is stored in the database server, there's a lot less vulnerability that someone's using the database in an inappropriate way because it's all inside the database. And right, we're not having to share the data outside the database and perhaps expose it to unwanted eyes. All right, so how can we compare stored procedures to triggers? Triggers are called by the database automatically when a table or a view is insert, update, deleted. And I think generally you're going to do some automated tasks in there to make sure that the constraints are followed or that those different things we saw, the default values. A stored procedure, on the other hand, is going to be called by a user or maybe the DBA, maybe an application. It's assigned to the database, so it's not specific to a particular table or view. And it's probably going to support administration or application kinds of tasks, so more general purpose than the triggers. So this is chapter 7. We've looked at SQL for database construction and application processing. We covered a lot of stuff, a lot of tools that exist in the database to try to make it easier to implement the business logic that the database is supposedly needing to follow. So we saw the new SQL categories that allow us to create and manage database structures. And we also saw, we got a taste of some of the tools that exist to implement logic in a database, like triggers and functions and the stored procedures. This is chapter 7. I hope that you've enjoyed it.